Hi there, welcome back everyone. In this section we're going to introduce the concept of a significant digit and discuss what that has to do with the accuracy and precision of a number. Here's an example. I've got two town population signs and they express the same basic stuff, but the city of Waterloo, the one on the left, population is 115,000. The one on the right, the population of Milwaukee, 596,974. What's the difference between the way that those two populations are reported? Well, you'd probably conclude the same thing I did, and although we don't know for sure, we would probably assume that Waterloo's population of 15,000, that's probably been rounded off, whereas Milwaukee's population of 596,974, that probably was not rounded. That's probably actually the number they got when they did their most recent census. Now, it is possible that Waterloo does have a population of exactly 115,000, but it's not likely. Those zeros sort of tell us that this number has been rounded off. Milwaukee doesn't have zeros in those spots, and so we tend to take them more seriously. So from a pretty early age, when we start getting used to numbers, we learn to take some numbers more seriously than others. Zeros we often assume have been rounded, but non-zero numbers we really have more faith in. And that's exactly what a significant digit is all about. That's what we're going to talk about in this unit. So here's a measurement. We measure the temperature of a room to be 24.3 degrees Celsius. When we talk about the accuracy of that measurement, we're talking about how well it actually represents the true temperature of the room or the true value of what's being measured. So anytime you measure anything, you want it to be accurate. If you're not close to the real value, you're wasting your time. Precision, on the other hand, precision is a measure of how specifically you're taking your measurement. So the temperature of 24.3 degrees, we can look at it and say, okay, yeah, it's fairly precise. 1/10 of a degree, that's pretty particular, but we would hope that it is accurate as well and that the room actually is about 24 degrees. So let's take that a step further and discuss what that actually looks like. Okay, so take the weight of a dog. We have this St. Bernard here, example A. He weighs 107.5 pounds. Now, if we put him on a scale, we could say, and it would be reasonably accurate to say that that St. Bernard weighs 100 pounds, right? It's not exact, but, you know, it's not wrong to say that. It would be more accurate to say that he weighs 110 because that's even closer to his actual weight of 107.5. So, 100 pounds, that's accurate. 110, that's more accurate. Yeah, we like accuracy. On the other hand, if we said that the weight of the dog was 672.15 pounds, well, that's not accurate. Because it's not even close to the dog's weight. But we did get really, really precise. We used a pretty high precision digital scale probably to get that 0.15 pounds on the end, but the scale is out of whack. So we got good precision. That is to say, it's very precise, but it is not very accurate. So at this point, I would ask you, when you get a measurement, when you take a measurement, would you rather have a measurement that has good accuracy, or would you rather have a measurement that has good precision? And I think after that example, you should conclude that we like precision, but we have to start with accuracy. 100 pounds isn't all that accurate, but it's way more accurate than 672. So even though that's not precise, there's no decimal points on there, we would probably start with the 100 pounds over the 672 because accuracy is more important than precision. Here's one more example. So we have a man who's 5 feet 11 inches tall. If we were to measure him, now in reality, he is 5'11". Now we're going to measure him, and we could measure him 4 different ways. We could measure him with poor precision and accuracy. We could measure him with poor precision but good accuracy. We could measure them with good precision but poor accuracy, or we could have good precision and accuracy. Okay, so let's look at an example of what each of these would look like. Let's start with not very precise and not very accurate. Take just a second and think, what kind of a measurement could we report that would be neither accurate nor precise for the height of this gentleman? Well, there's lots of different answers to this, but I would offer 10 feet. Remember, one tick mark represents feet. If we said he's 10 feet tall, that's garbage. That's not very accurate, and it's not very precise. So we have poor accuracy and poor precision. Now, we could get more accurate. We could keep the same precision and say we're only measuring him to the nearest foot, but we'd be better off saying that he's 6 feet tall. Now, that's not that far off. He's actually 5'11", so we're only about an inch off here with our 6-foot measurement, and so we've gotten more accurate. Now, what if we gave up our accuracy and went for precision? What if we said that he was 10 foot 5 3/16 of an inch tall? Again, 2 tick marks represents inches. 10 foot 5 3/16. Very precise. Wow. Somebody was super careful in reading that ruler or tape measure when they measured him. The problem is that that's not accurate at all. So we have poor accuracy, but pretty good precision. But what would a high accuracy and high precision measurement be? Well, maybe this guy is actually 5'11" and 1/8 inches tall. There. Now we've got a fairly accurate, it's close to the real thing, and a fairly precise measurement. We like that. So when we look at measurements, we can actually quantify how accurate and precise our measurement is, and we do that by looking at significant digits. So we're going to look at what a significant digit is next. In a given number or a measurement, not all the numbers are taken as seriously, or not all of them are considered significant. So there's 3 rules towards recognizing significant digits, and with a little practice, these will be very intuitive. First of all digits 1 through 9 are significant. That's why that population sign on the first slide was kind of perceived differently. So 1 through 9, always significant. Those are never rounded digits. If you have a 0 between 2 other significant digits, then that automatically makes it significant. And zeros that are in place to show precision beyond the decimal point, those are also significant. All other zeros are not significant. Specifically, digits that are not significant are only those leading zeros and zeros that are used to locate the decimal point. So let's take a look at a few examples of some numbers and identify how many significant digits each of these has. First of all, 67 pounds. How many sig digs are there? Well, 6 and 7 are both non-zero, and so we would say that those are both significant digits, and so for short we call them sig digs. 2 sig digs in that number. Okay. What about 607? The 6 is significant because it's not a 0. The 7 is significant, but then the question is this 0 significant? And it is, because zeros between other sig digs are automatically significant. So in this case, all 3 of them are significant. We would say that that number has 3 sig digs. 670, very similar. The 6 is significant, the 7 is significant, so there's 2. But the question is that last 0 significant? And as it turns out, it's not. Intuitively, that 0, we would probably assume that this weight was rounded off to 670. And so that 0 would not be significant. It's only there to push the decimal point out to the right. If that 0 weren't there, our number would be 67. So the 0 is only pushing the decimal place out. It's probably been rounded off to 670. We wouldn't take that seriously. That number only has 2 sig digs in it. What about 67.0? Certainly the 6 and the 7 are still significant, but then the question is that 0.0 significant? Now, if you take that 0 out the decimal place doesn't move. Therefore, that 0 has another job. That 0's job is not just to locate the decimal point. That 0 shows that your scale weighed out to the 10th. It is significant. It shows precision. It's a case of this last one. Zeros that show precision beyond the decimal excuse me, are significant, and so this measurement has 3 sigdigs. Okay, let's look at just a couple more examples. 1,000 years. That number's probably been rounded off. We would say that the 1 is significant, but those zeros are probably just rounded off digits, and so this number only has 1 significant digit in it, and it is the 1. What if we said 1,000.0 years? We found an artifact that was 1,000.0 years old. Well, that 0 would be significant because that 0 is showing precision. It shows that we were able to calculate or measure that time very carefully. So there's our second significant digit. And then, curiously enough, because the other zeros are between these two other sigdigs, they also become significant. And so suddenly, by putting 0.0, we now have 5 sigdigs. If we take that last 0.0 seriously, we have to take all those intermediate zeros seriously as well. So that number has 5 sigdigs. What about 1,000.000? That 1 is significant. These 3 zeros are significant. They're showing careful precision. And then because of a sigdig sandwich here, these other zeros are also significant. We must have 7 sigdigs. Okay, I'd like you to take just a minute, look at each one of these 6 numbers, and count the number of significant digits in each of these numbers. You can pause the video and resume it after you've done your count for each number. Okay, let's take a look. 00800. Certainly that 8 is significant, but really, this is the number 800. Those zeros in front, those don't mean a thing. So the number is really 800. So when you hear the number 800, you wouldn't necessarily assume that it's exactly 800. If we had a town of population 800, we'd assume that was rounded. These zeros are probably rounding digits. So 8 is the only actual sigdig here. We would say that that number has 1 sigdig. 817,001. Certainly the 8 and the 1 and the 7 are significant. That 1 is significant. And that kind of tells us that we have to take these zeros in the middle seriously. They must really be zeros if that's really a 1, and therefore this number has all 6 sigdigs. 500, that's like 800. The 5 is significant, but those zeros have probably been rounded. This number only has 1 sigdig. Number 9, not much to do there. That's a non-zero number. It's significant, 1 sigdig. But if it comes 9.0, now that 0.0 is showing precision. Okay, well, that's a little bit more precise. That is a significant digit. It's not just locating the decimal, it's showing precision, and so therefore we have 2 sigdigs. 6,000,000.000, significant. These zeros show precision, they're significant, and therefore all those in the middle become significant. There's all 10 digits there are significant. Now this brings up the next question. When you look at a calculator or a computer, do they generally consider zeros to be significant digits? In other words, does a computer or calculator generally recognize what a significant digit is? The answer is no. Every zero in a calculator or a computer is always assumed to be a significant digit. If your calculator computes a value of 700 or 7,000 or 70,000, it always means that exact number. Your calculator never assumes that that number should be rounded off. It never rounds for you. It always assumes that you'll round it accordingly. And that's why when we look at numbers and do calculations, we have to interpret what the significant digits are and which ones they're not. The reason we need to recognize the number of significant digits in a number is that is the way that we measure accuracy. The number of significant digits determines the accuracy of a number. So if we say a population of a small town is 1,300, that is accurate to 2 significant digits. If we said the town's population was 1,326, well, now we're measuring it more accurately, and we'd say it's accurate to 4 significant digits. So we've gained a level of accuracy. A mouse is weighed. It weighs 0.1 pounds. How accurate is our measurement? We'd say it's accurate to 1 significant digit. But if we weigh that mouse and measure it to be 0.100 pounds, well, now we would say that it is accurate to 3 significant digits. So we have more accuracy. We've gotten even closer. That assumes, by the way, that our measuring tool is correct. If we have a scale that's way out of whack or out of calibration, it might not even be reporting that. So we assume the measuring tool is doing its job correctly when we say that. Precision. So how do we measure precision? If we measure accuracy by the number of significant digits, how do we measure how precise a number is? Precision of a number is determined by the location of the last significant digit. So if we look at the number 4,500, there's 2 sigdigs there. That's how accurate it is. But where is the last significant digit? Well, 4 and 5 are the 2 significant digits here. The zeros are not. And the last sigdig occurs in the hundreds place. And so we would say that this number is precise to the nearest 100. Another way to say that is this number was probably rounded off at the nearest 100. Town has a population of 4,500. We wouldn't assume that's exact. We would assume that that is rounded off. .590. Well, our last significant digit is this 0. Remember, it's showing precision. And so since that is the last significant digit, and it's in the thousandths place, we would say that number is precise to the nearest thousandth. So it's not how many sigdigs, it's where the last sigdig is located. 225. The last significant digit is the 5. That's the last spot before the decimal place. That's the whole number spot. And so we would say that that is precise to the nearest whole number. If you had a dog that weighed 225 pounds, yikes, you would assume that that weight was rounded off at 225 pounds and that the dog may have had a few extra ounces as well. Okay, so we have a bunch of numbers here, and we want to determine what the accuracy and precision of each is. That's the main goal of this section. So let's do a few together, and I'll leave you a few for practice. Our first one, 0.065, accuracy. Remember, accuracy is how many sigdigs? 6 and 5 are the 2 sigdigs. These zeros are only locating the decimal, and so we would say that there are 2 significant digits. Therefore, our accuracy is 2 significant digits. What's our precision? Our precision is where it occurs. That is the thousandth or .001 place, and so our precision is to the nearest thousandth. 125. All 3 of those are significant. Our accuracy is 3 sigdigs. Precision, where was this number rounded to? It was rounded to the nearest whole unit. 9,000.0. The 9 is significant. The 0 is significant. All the others must be as well. We have 5 sigdigs there. Precision, where is the last sigdig? Well, this 0 right here is our last significant digit, and so we could say that that is precise to the nearest tenth. I would like you to do the last 4 problems. Pause the video, do those 4, determine the accuracy and precision, and resume the video when you're done to see if you've gotten them correct. Okay, let's take a look. 500. That 5 is significant, but the zeros are not. They've probably been rounded. We only have 1 sigdig in that number. How precise is it? Well, where is that 5? That number has been rounded off to the nearest 100. 0.0007. That 7 is significant. These zeros are the tricky ones. They feel significant, but they're not. All they're doing is pushing that decimal place out to the left. And if that's all it's doing, those zeros are not significant. And so that 7 is the only sigdig. But it's occurring way out in the 4th decimal place. Just to review those decimal places, the first one is our 10th, the second one is our 100th, the third one is 1000th, this one is in the 10,000ths place. This is accurate to the nearest 10 hyphen thousandth. 8.0073, 8 is significant. The 7 and 3 are significant, therefore the zeros in between are as well. There are 5 sigdigs there. That one also has precision to the 4th decimal. It is also precise to the nearest 10,000th. And our last one, 60,500. 6 is significant, the 5 is significant, the 0 becomes significant because it's stuck in the middle, but those last 2 zeros are not. There are only 3 sigdigs here. And the last significant digit is the 100. It was probably rounded off to the nearest 100. And that's our precision. Okay, that wraps up the topic for this section. You'll have a corresponding Blackboard assignment to do. Go ahead and do that. And as always, stop by the Learning Commons or let me know if you need help with this topic. It's kind of a tricky idea, so there's no shame in getting a little extra explanation if you need it.